Hi everybody. So in this video we're going to look at how we multiply with matrices. So matrices can be multiplied together if the number of columns in the first matrix is equal to the number of rows in the second matrix. So the product of an n by m matrix and an m by p matrix has the order n times p. We can see how it works from this example. If we have an n by an m multiplied by an m by a p, well, these two m's are the same, so what we're left with is an n by p, okay? As we go through some examples, we'll see how this works more clearly. If the two matrices can be multiplied, then they are said to be conformable for multiplication. Okay, so if we work through these examples, we can see that matrix A has 3 rows and 2 columns, so this is 3 by 2. And matrix B has 2 rows and 2 columns, so this is 2 by 2. We will have to begin by finding the product of matrix A and matrix B. So this will be the 3 by 2 multiplied by the 2 by 2. We can see that the number of columns in the first is equal to the number of rows in the second, so the product will give us a 3 by 2 matrix. So if we write down matrix A, we've got 2, 1, negative 3, 0, 3 and 5, multiplied by matrix B, 5, 0, 1 and negative 2. So the way we do this is we multiply every element in the first row by every element in the first column. Then the elements in the first row multiplied by the elements in the second column. Second row, first column, and then the second row, second column. Third row, first column, and the third row, the second column. So we'll begin with the first row and the first column. We've got the 2 times the 5, which will give us 10. We'll put this in square brackets. And then we'll have the 0 multiplied by the 0. So this is the element in the first row and the first column of our 3 by 2 matrix. And then the next element will be the first row times the second column. So 2 times 1 plus 0 times negative 2. And then the second row times the first column. So 1 times 5. And then the 3 times the 0. The second row times the second column. So 1 times 1. And 3 times negative 2. And then the third row times the first column. So negative 15 plus the 0. And then the third row times the second column, which will give us negative 3. And 5 times negative 2 is negative 10. So now we can simplify each of these, and we get 10, 5, negative 15. And for our second column, we've got the 2, 1 take away 6 is negative 5, and a negative 3 take away 10 is negative 13. So you can see that we do have a 3 by 2 matrix, 3 rows and 2 columns. And we can check this on our calculators. If we go to menu, we want option 4 for matrix, then we want to define this matrix A. So we'll press 1 for matrix A. It has 3 rows and 2 columns. The first element is 2, and then 0, and then 1 and 3, negative 3, and positive 5. So now if we go to option, we'll define matrix B, which has 2 rows and 2 columns. The elements are 5, 1, 0, and -2. So now we've entered matrix A and B, we go to Option. We want 3 for Matrix Calc, and then Option A for Matrix 3, multiplied by Option 4 for Matrix B. And you can see we do get 10, 2, 5, -5, and -15, -13. Okay? Let's try question B. Okay, so for question B, we've got a product of B and A. We know B is a 2 by 2 matrix, and A is a 3 by 2. And you can see that because the number of columns in the first matrix does not equal the number of rows in the second, the product BA is not possible. So for question C, to work out A squared, this will be 3 by 2 matrix multiplied by itself. And again, because the number of columns in the first does not equal the number of rows in the second, this is also not possible. So for question D, we've got B, which is 2 by 2, multiplied by itself. And you can see that this is possible. So we'll get a 2 by 2 matrix. And when we square matrices, the original matrix has to be a square matrix, which means the number of columns is equal to the number of rows. So if we have matrix B, 5, 0, 1, -2, multiplied by itself, so we begin by multiplying the first row by the first column. So we get the 5 times the 5, which is 25. And then the 1 times the 0, which is 0. Then the first row times the second column. So 1 times 5 is 5. Take away the 1 times the 2. Then the second row times the first column. 0 and 0. And then the second row times the second column. So 0 times 1 plus the -2 times -2. So this will be B squared. Okay? Let's try one more example. So in this example, we've been asked to calculate the product of AB in terms of A, which is this A here, and then to simplify each element where possible. So we can see that matrix A is a square matrix, 2 by 2, and matrix B is 2 by 3. And because these two are the same, the product will be a 2 by 3 matrix. So we'll have 3A, 2, 1, and -1, multiplied by 1A, 3, 2, and then 2, -A. So we'll have the first row multiplied by the first column. So 3A times 1 plus 2A will give us 5A. And then the first row times the second column. 3A times 3 is 9A. And then the 2 times the 2 will give us 4. Then we'll have the first row times the third column. So we'll have 3A times 2, 6A. And then the 2 times the -A, so -2A. The second row times the first column. So 1, take away the A. The second row times the second column. So 3, take away 2. And then the second row times the third column. So 1 times the 2 plus -1 times -A. So 2 plus A. And then we can tidy this up. So we get 5A, 9A plus 4. This becomes 4A, 1 minus A, 1, and 2 plus A. Then this is the simplified version of the product AB. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. Another link in the description below. Thanks again, and take care.